Hi, welcome to our math. Today I'm doing a series of videos on rational expressions and equations. This video specifically on rational equations. When the word rational means fraction, equation means there's an equal sign. And when I have a rational equation, my first goal is to clear my fraction. There's no reason to have to manipulate fractions when you have an equal sign. So to clear my fraction, I need to find my least common denominator. Well, there's an x, so I know an x has to be involved. 2 and 4. You always start with your biggest number, and since 2 is a factor of 4, my least common denominator is going to be 4x. One of the reasons we look for a least common denominator is denominators can't be 0, so my domain is x cannot be 0. And it's really good to acknowledge that x cannot be 0, so that if you get 0 for your answer, you know it's not valid. So what I'm going to do is there are 3 terms, and I'm going to do this problem and the next problem differently so you can see the 2 ways of doing it. The way I normally do this is I take my least common denominator and multiply it to each of my fractions, but I do it in line. I do it right on my original problem. If you have bigger handwriting, you might want to rewrite it bigger. But I just come through and I write times 4x, times 4x, times 4x. I make sure I hit all my terms. But this saves me a little bit of writing, and these problems get really long. So anytime you can save a little bit of space, I find it advantageous. All right, my x's cancel, and 2 times 4 is 8. 2 goes into 4 twice, and 1 times 2 is 2, plus 2x. My 4's cancel. 1 times x is x. I subtract 2x from both sides. Look how quickly this problem went from something that looked really ugly to, solved. Divide by -1, -8 equals x. -8 is not 0. I would suggest plugging it back in to check the work. I would always suggest doing that. I'm going to leave that to you, but you really should always make sure you check your work. For my second equation, I have 4 terms, 1 denominator. The only denominator I have is x plus 7. So my least common denominator is going to be x plus 7. And what makes x plus 7 0 is a -7. So I need to restrict x, that x cannot be -7. That will be my domain. Okay. Before I multiply through to each term, that's 4 terms, that's a lot of multiplication, I note that the 8 and the 4 are like terms. They're both just constants. So I'm actually going to start by adding 8 to both sides to save myself a little bit of work. I'm going to throw the negative up into the numerator. I can put it out front in the numerator and the denominator. I prefer it in the numerator. I find it's the cleanest way to look at a fraction. -2 over x plus 7 equals x plus 4. In this case, I'm going to multiply the x plus 7 to both sides. So I'm going to multiply this side by x plus 7 over 1, and I'm going to multiply this side in its totality by x plus 7. I'm going to multiply this out. X squared plus 7x plus 4x plus 28. And I'm going to get x squared plus 11x plus 2. 28. On the left-hand side, the x plus 7s will cancel, and I'll be left with -2. Now, your instinct is to then factor, which is where we just came from. But the thing is, there's no rule in math that says 2 numbers multiply together, they equal -2. Actually, there's only one situation where one is -2 and the other is 1. In every other situation, neither of the factors is -2. However, there is a rule in math that says if 2 numbers multiply to be 0, one of the numbers has to be 0. So if I add 2 to both sides to get this to equal 0, I have that 0 is equal to x squared plus 11x plus 28. Now that I have this in this form, I can factor. Let's see, 28, 1 and 28, 2 and 14, 4 and 7. I didn't add them. 30. Why didn't you tell me I didn't add them? 30. Let's try this again. 1 and 30, 2 and 15, 3 and 10, 4, 5 and 6. There we go, 5 and 6. That looks better. So 0 equals x plus 5 times x plus 6. Now, the only way that this is 0 is if x is equal to -5 or -6. I do a quick check with my domain. -7 isn't in my laundry list. I double check by plugging them back into my original equation, which I'm going to leave for you to do, and I highly suggest you do it. And then I call it good. I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I will see you on my next video. Thanks.